A very warm greetings to everyone. This is Dr. Anand here. Today I would be taking you through one of the most important activity in HR analytics, that is the employee churn prediction using the logistical regression model in KNIME. So to facilitate this, let me first talk about one of the most important aspect in human resource management, that is the churn prediction. If you look into the human resource statistics, which has been published by many organizations, not only the domestic market or the national market, but even the international markets are facing a lot of employee attrition. So, employee attrition is all about the employees who are likely to leave an organization. And this could be because of different types of factors. Probably it could be because of the very low job satisfaction, or they don't have a proper balance between the work and their personal commitments, or it could also be because of the growth factors which are lacking in the organization. So, these are all the potential factors which might motivate any employee to depart or to put themselves into the departure stage from any organization. So, this becomes a very huge ruckus and a trauma for the HR management. The reason is because finding the right employee for the right job at the right time at the right salary, who can exclusively work as per the vision, mission, and objectives of the business is very difficult. And it also involves a lot of financial factors also. It's a cost if the HR department is going to continuously involve in the recruitment process, and after 6 months or 1 year if the employee leaves the organization, it is going to be a nightmare for the entire organization. To facilitate this, I've taken a data set which is very much available from Kaggle, which is called the Employee Churn at the Dunder Mifflin Paper Company. So this particular paper company, which is called the Dunder Mifflin Paper Company, it's a mid-sized supplier of paper products. It operates in the United States of America, and it has 12 branches. So while this company had a very good reputation in the market for the past few decades, but unfortunately, due to the changing market conditions and due to the economical factors, the employees are leaving the organization. So you can ask me a question. The HR department can always look for the new employees who can be replaced in the position of those who are leaving the organization. But let me tell you, this is a production company which is supplying paper products. So what happens if the employees are leaving? Production technique is not a very easy technique where easily it can be taken forward by the new employees, because it deals with a lot of quality aspects. So when the production stops, the distribution stops. When the distribution stops, the marketing stops. When the marketing stops, the sales would stop. And when the sales stops, the profits for the company would stop. And if the profits stop, the company will be pushed to a gray zone or to a red zone, and it might become bankrupted. So these are all the different types of complications. So never look only from the perspective of the HR, but also look in a holistic view. So now let me talk about the data set. So this data set is very much collected from the employees who are working in this Dunder Mifflin Paper Company. And as I've told you before, it has 12 branches which has been spread across the United States of America, and it has been collected from all the branches. So now let us look into certain things what we have to do before starting with the analysis. Any type of data what you collect for analysis might not be giving you a holistic picture, because there can be a lot of missing values and a lot of errors. So that is one of the reasons why we have to prioritize on the potential analytical approach, where we have to clean the data. So you have to look into the data, you have to take care of the missing values and pre-process the data. The second important one is the managerial insights. So managerial insights is really going to help the HR department. So the employees can be promoted, or they can be given a better career progression so that the retention strategies can be executed, implemented, and the employees can be retained. Second, flexible work hours can be given, or maybe if employees are working for a double shift, they can be asked to work only for a single shift. This could help the employees strike a very good balance between the personal life and the professional life. The third important one is the compensation strategies. So, competitive pay alone is not sufficient, but also the non monetary rewards is a source of recognition and motivation. So, this will help the employee to be over motivated. And the fourth important point is more important. I've told you before that the data has been collected from 12 different branches. The leadership, the supervision, communication, hierarchy, work culture, organizational citizenship behavior is not going to be the same across all the 12 branches. It might differ. So, a commonality can be brought so that the employees might face a common policy, a common work culture, a common ground. The last one is the challenges. As I've told you, any type of data what we collect might be quantitative or it might also be qualitative. Let me give you a very simple example for a quantitative data. Salary. Salary is expressed in numbers. But if you take department, it is a qualitative data. Likewise, job satisfaction, which has been scored in a scale from 1 to 5. So this is an example for a qualitative data, but which has been quantified for the purpose of analysis. Likewise, for work-life balance, for commuting distance also. So the data which has been collected from the employees has 16 different iterations, that is 16 different categories. Employee ID, tenure, salary, department, job satisfaction, work-life balance, commuting distance, marital status, educations, performance rating, training hours, overtime, number of projects, years since promotion, environmental satisfaction, and branch. The concept of environmental satisfaction is nothing but the organizational climate that is mentioned as environment. So, usually when we deal with the logistical regression, you have to divide the churn into two. That is highly likely to leave or slightly likely to leave. But sometimes you can also go for three different classifications or classifications as per your expectations. So the classifications what I have brought in this analysis is highly likely to leave, moderately likely to leave, and slightly likely to leave. So now let us get into the very important concept, that is a logistical regression. So the logistical regression is a supervised learning algorithm. What do you mean by the concept of a supervised learning algorithm? I'll give you a very simple example. Just imagine that you have a fruit basket and that fruit basket has randomly many different fruits. You close your eyes and you put your hands inside and randomly you pick up a fruit. So the first fruit what you have taken is round in shape. It has a dent on the top and in the bottom. So your mind automatically says that you have taken an apple. So based on the features of the apple, you are able to predict that you are having an apple in your hand. The same concept has also been used for the machine learning, which is supervised. You supervise the algorithm by asking it to classify based on the attributes, features, and characteristics. Then we also have three different types of logistical regression. Binomial logistic regression means two categories. I'll give you an example for that. Yes or no. Attrition prediction. If the employees are leaving, it is yes. If the employees are not leaving, it is no. The next one is multinomial logistical regression, which has more than two categories, but it is not in proper order. I'll give you a very simple example. The HR department is collecting information pertaining to the reasons of absenteeism from, say, 1,000 employees. So few might say medical facilities, family issues, personal workload, personal commitment, a lot of different types of things might be there. So this is an example for multinomial classification, but it is not in proper order. Finally, we also have the third one, that is the ordinal logistic regression. This also has more than two categories, but with a natural order. Say for example, employee satisfaction level. employee satisfaction level. So when I'm talking about the concept of level, it is low level, medium level, high level. So it is having more than 3 categories, and it also has a very natural order. So the logistical regression plays a very important role. It helps the HR department to take a lot of important decisions. So each employee data should be independent, which is one of the biggest observation. Second, we have to be in a position to predict the outcome in a bivariate category, that is churn yes, churn no. Large sizes of sample data is much needed. So I'll give you a gist of summary on logistical regression. It predicts probability of attrition. It can handle mixed type of data. You can be in a position to interpret in a very transparent manner. It is very much suitable for binary outcomes. It helps the HR department and the top management to take a lot of strategic decisions and to set the benchmark for improving the organization in the whole. So these are all the 12 different types of features of a logistical regression. The same thing what I've mentioned before. Now, first and foremost, you have to clean the data because sometimes we will be having numbers and string. So what is the workflow? First, we would be using an Excel reader node. Second, we'll be using a missing value node. Then we'll be using a partitioner node. Then we'll be using logistical regression and logistical learner and predictor. And then we would be evaluating the model using a scorer node. Of course, you can use an ROC also, that is receiver operating characteristics, exclusively used for visualizing the binary logistical regression. But you can also stop with the scorer node, which talks about the accuracy, precision, recall, and the confusion matrix. So in simple, the first step is importing the data. Second one is data cleaning and preparation. Third is training and testing the data, where the data will be split into 70% and 30%, where 70% will be training and remaining 30% will be testing. And then we'll be building the model using logistical regression, which is again bifurcated into regression learner and regression predictor. And then finally, we would be evaluating the model by checking the accuracy, precision, recall. So this is going to be the workflow. First an Excel reader node, then the missing value node, then the column filter node, then the normalizer node, then X partitioner, then table partitioner, logistical learner, and logistical predictor, and finally we would be having the scorer node. Now let me walk you through the KNIME platform. KNIME platform, we will be performing the analysis step by step. The most important one when you are performing any type of analysis is that you have to make a note of each and every nodes what we are going to use. So now this is my workflow. The very first thing is to take my Excel reader node. So I'm placing it in my workflow. I'm right clicking. I'm going to configure and I'm going to take the data from where I have saved it. So I'm already having it. That is the employee churn prediction data. And then I'm going to execute it. Now you can see that we have a green signal and the data has been successfully executed. So let us introspect the data. The data has been collected from 1175 employees, which has been distributed in 17 different types of columns. Of course, when you looked into this particular data, it has a lot of missing values. So let us use a missing value node to clean the data. I'm going to connect the Excel reader node to the missing value node and then I'm going to configure. So we usually give to remove the nodes because we do not want any biased answers. So I'm also going to give the same thing, that is remove the node, remove the rows. Right click and execute it. Now you can see that the data has been reduced from 1175 to 880, which means there are a lot of missing values. So this is also an eye opener for the HR department to state that the HR department has not taken a lot of efforts to collect the data properly from the employees. So what is the third important node? We take a column filter. So when you type column filter in your node repository, you get multiple column filters, but you have to take the column filter legacy. So why should we use a column filter? You can see automatically that all the 17 variables are in the inclusion box. But employee ID is not needed. It is not going to create a huge difference in your analysis. It might indeed create an error. So because it is a combination of integer and a string, if you look into it, the row ID, employee ID. So I have removed it. Next, I'm going to use a normalizer node. So why should we use a normalizer node? See, we have a lot of numerical data. Salary has a very different numerical structure. Employees performance score has a different numerical structure. So there is no uniformity and commonality. So that is why we try to normalize the data. Next, we use a X partitioner. An X partitioner also will help you to divide the data into training data and the split data. You just have to execute it. Automatically it will do it. For example, you can see it has two tables, training data and testing data. We also use the table partitioner node here, where you have to connect the X partitioner to the table partitioner, and then you also have to take your logistical regression nodes. So when you type logistical regression, you get the logistical learner and then you get the logistical predictor. First is always the learner and then only we take the predictor. So I'm connecting my X partitioner node to my learner. I am connecting my table partitioner to my predictor. I'm going to connect my learner and predictor. So what should be the configuration what we have to give here? That is the most important one. But before getting into the logistical regression predictor, let us first give importance to the learner. So this is how the learner node configuration menu will be looking like. So we have taken churn likelihood, but I want to look for highly likely to churn. And one of the most important things in advance is the epochs. So which means the data would be rotated multiple times. So the more epochs you give, it might give you a better outcome, right? So usually 10,000 to 15,000 is good, but based on your data, you can increase it. So for now, let me give 20,000. And then let us click apply, let us click OK, and let us execute it. So if you don't get a green signal, it means that your model has not been properly tuned, right? So you might not be getting a proper answer. Now we have also given importance to this custom prediction table, that is a churn prediction. That is going to be our final output, right? So we have to give importance to that. And how do you evaluate it? We can go for a scorer node, because I've told you before the importance of a scorer node. So now you have to configure. So we are going to predict the likelihood of the churn prediction, apply and OK. So let us see what is going to be the output here. So if you look into it, we have accuracy of 98% and only one wrong classification is there. And from this confusion matrix, you can see that almost majority of the employees are in a position to leave. So how do we understand this? The logistical regression model for the churn prediction is highly accurate because we have received almost 98% classification accuracy and a very strong agreement, that is the Cohen's kappa. The Cohen's kappa is almost close to 0.90, which states that the data also is more reliable. So among all the predictors, if you go through it very keenly by using ROC curve and decision trees, we can come to a conclusion that The branch data has to be relooked. Probably the logistical regression model for churn prediction has to be done 12 times based on the branch data. So the logistical regression analysis demonstrates that the churn prediction in employee is not just a mathematical exercise, but it is a strategic HR decision making tool. So with the overall accuracy of almost 98% and Cohen's kappa score of zero point 0.9 and above, the model has proven to be reliable and statistically valid. So from an HR perspective, the significance of these results lies in the ability to identify the workforce attributes most strongly associated with the attrition risk and to distinguish between employees who are falling in the category of highly likely to churn and moderately likely to churn. So the HR department should really look into this particular data so that it can relook into certain predictors like job satisfaction, environmental satisfaction, year since promotion, work-life balance, etc. Although I would say that this data set is a very small data set, but it is a very clean data set. But there was one particular issue that when we cleaned the data using the missing value node, a lot of data were omitted. So maybe in future, if the HR really wants to take a very good decision and some strategic implementation for the organization's benefit, the data has to be properly collected. The second important point, they have to relook into the predictors. They have to have a personal face-to-face feedback session with the employees. Strategic decision has to be taken with the consultation of the top management, and the HR and the team should ensure that the employees are not leaving the organization. So I hope you have understood how the logistical regression can be performed in a very simple way. In the next video, I would be talking elaborately on the random forest method and the decision trees. So thank you all so much, and I really appreciate your comments and feedback.